Good morning. Good morning, students. This is the last topic in thermal energy based process, which is called plasma arc machining, PAM, or plasma jet machining, which is called PJM. Introduction. Solids, liquids, and gases are the three familiar state of matter. In general, when solid is heated, it turns to liquids, and the liquids eventually becomes gases. When a gas is heated to sufficiently high temperature, the atom's molecules are split into free electrons and ions. The dynamical properties of this gas of free electrons and ions are sufficiently different from the normal unionized gas, so it can be considered a fourth state of matter and is given a new name called plasma. In other words, when a following gases is heated to a sufficiently high temperature of the order of 11,000 degrees Celsius to 28 degrees Celsius. It becomes partially ionized and it is known as plasma. This is a mixture of free electrons, positively charged ions, and neutral atoms. This plasma is used for metal removing process. Plasma or machining process is used for cutting alloy steels, stainless steels, cast irons, copper, nickel, titanium, and aluminum, etc. Now we are going to see the principle of a plasma arc machining. In plasma arc machining process, material is removed by directing a high velocity jet of high temperature 11,000 degrees Celsius to 28,000 degrees Celsius. Ionized gas on the workpiece. This high temperature plasma jet melts the material of the workpiece. This is the schematic diagram of a plasma arc machine. Now we will see the construction of the plasma arc machining. The schematic arrangement of a plasma arc machining is shown in the figure. The plasma arc cutting torch carries a tungsten electrode fitted in a small chamber. This electrode is connected to the negative terminal. This electrode is connected to the negative terminal of a DC power supply, so it is act as a cathode. The positive terminal of a DC power supply is connected to the nozzle formed near the bottom of the chamber. So nozzle acts as an anode. A small passage is provided on one side of the torch for supplying gas into the chamber. Since there is a water circulation around the torch, the electrode and the nozzle remains water cooled. Now we are going to see the working principle of the plasma arc machine. When a DC power is given to the circuit, a strong arc is produced between the electrode cathode and the nozzle anode. A gas, usually hydrogen H2 or nitrogen N2, is passed into the chamber. This gas is heated to a sufficiently high temperature of the order of 11,000 degrees Celsius to 28,000 degrees Celsius by using an electric arc produced between the electrode and the nozzle. In this high temperature, the gases are ionized and large amount of thermal energy is liberated. This high velocity and high temperature ionized gas plasma is directed on the workpiece surface through nozzle. This nozzle jet melts the metal of the workpiece and the high velocity gas stream effectively blows the molten metal away. The heating of the workpiece material is not due to the any chemical reaction, but due to the continuous attack of a plasma on the workpiece material. So it can be safely used for machining of any material including those which can be subjected to chemical reaction. The accuracy of a plasma arc machining. Plasma arc machining is a roughly operation to an accuracy or around 1.4 mm with a corresponding surface finish. Accuracy on the width of the slots and the diameter of holes is ordinary from plus or minus 4 mm on 100 to 150 mm thick plates. Next, we are going to see about the gases used in plasma or machining. The selection of a particular gas for use in this process mainly depends on the expected quality of surface finish on the work material and economic consideration. The gas used in this process should not affect the electrode or the workpiece to be machined. The commonly used gases and gas mixtures are given in the following table. Gas or gas mixtures, material to be machined. Nitrogen, hydrogen, argon, hydrogen. Stainless steel, non-ferrous metals or materials. Second one, nitrogen, hydrogen, compressed air. Carbon and alloy steels, cast irons. Nitrogen, hydrogen, argon, hydrogen. Aluminum, magnesium. Next, next types of plasma arc machining. Direct arc plasma torch or transferred arc type. Second one is indirect arc plasma torch or non-transferred arc type. Direct arc plasma torch. Indirect arc plasma torch. Direct arc plasma torch electrode is connected to the negative terminal cathode of a DC power supply and workpiece is connected to the positive terminal anode of a DC supply. Power supply. So more electrical energy is transferred to the work, thus giving more heat to the work. Since it is difficult to strike an arc between the electrode and workpiece directly through the narrow torch passage, first an auxiliary arc is connected. It is commonly produced between the electrode and the nozzle. When the arc flame reaches the workpiece, it automatically strikes the main arc between the electrode and the workpiece and the auxiliary arc is switched off. Direct arc torch has higher efficiency and this type of arc is preferred for cutting, welding, depositing, etc. Indirect arc plasma torch. In these type of torches, electrode is connected to the negative terminal cathode of a DC power supply and nozzle is connected to the positive terminal anode of a DC power supply. When the working gas passes through the nozzle, a part of the working gas becomes heated, ionized and emerging from the torch as the plasma jet. This plasma feeds the heat to the workpiece. This type of torch are used for non-conducting materials. In many cases, plasma torch with a double or a combined gas flow are used for welding and cutting. Primary and secondary gases can differ in the designations, compositions, and flow rate. In cutting process, the primary gas, usually inert gas, protects the tungsten electrode from the environment. The secondary gas, usually active gas, is used for forming plasma. Characteristics: metal removal technique: heating, melting, and vaporizing by using plasma. Work material: all materials which conduct electricity. Tool: plasma jet. Velocity of plasma jet: 500 meter per second. Power range: 2 to 200 kilowatts. Current: as high as 600 amps. Voltage: 42 to 50 volts. Cutting speed: 0.127 meter per minute. MRR: 145 cubic per minute. Next is process parameters. In process parameters, standoff distance is the important criteria. Standoff distance. Standoff distance is the distance between the nozzle tip and workpiece. When the standoff distance increases, the depth of penetration is reduced. With an excessive reduction of the standoff distance, the plasma torch can be damaged by the metal spatter. The optimum standoff distance depends on the thickness of the metal being machined and varies from 6 to 10 mm. Applications: it is used for cutting alloy steels, stainless steels, cast iron, copper, nickel, titanium, aluminum, and alloy of copper and nickel, etc. Second, it is used for profile cutting. It is successfully used for turning and milling of hard to machine material. It can be used for stack cutting, shape cutting, piercing, and underwater cutting. Fifth, uniform thin film spraying of refractory materials on different metals, plastics, ceramics is also done by plasma arc. Next is advantages of plasma arc machine. It can be used to cut any metal. Cutting rate is high. As compared to ordinary flame cutting process, it can cut plain carbon steel 4 times faster. It is used for rough turning of very difficult materials. Due to the high speed of cutting, the deformation of steel of sheet metal is reduced while the width of the cut is minimum and the surface quality is high. Disadvantages of PAM, plasma arc machine. It produces tapered surface. Production of noise is necessary. Equipment cost is high. Production of ice is necessary for the operator and persons working in nearby areas. Oxidation and scale formation take place, so it requires shielding. Work surface may undergo metallurgical changes. Thank you.